We, the Indian Society of Heating, Refrigerating and Air Conditioning Engineers, ISHRAE, stand tall in the Indian industry with over 10,000 professionals as members and almost an equal number of student members. Founded in 1981 and headquartered in Delhi, we operate from chapters and sub-chapters spread all over India, bringing our entire industry together. Individuals become members of our society according to their professional and academic standings. Our roadmap of the future looks very bright, with thousands of new members joining this technical society every year and bringing in a fresh outlook to our industry intelligence. ISHRAE disseminates knowledge through its technical committees, which consists of some of the best minds of our industry. It publishes technical books, newsletters, and a prestigious journal, distributing the wealth of knowledge to all its members. Working with government departments, ISHRAE helps formalize industry codes and standards. ISHRAE promotes research by offering financial support to student members to carry out groundbreaking work in technology, systems and processes. Our educational wing, ISHRAE Institute of Excellence, organizes training programs and workshops to help members enhance their skill sets. Our specially designed certification programs under ICP, that is, ISHRAE Certified Professional, empower professionals to always be in step with the prevailing technology. Specially designed courses for technicians are offered to meet the ever-increasing demand for a skilled workforce. ISHRAE organizes exhibitions, conferences, panel discussions, and product presentations throughout the country. We organize the industry's largest international exposition in South Asia, Acrex India, to showcase the cutting-edge technology, innovation, and provide a platform for closer interactions amongst the decision makers in the industry. The Acrex exhibition is now growing from HVAC&R show into BFA, Build Fair Alliance. This brings together several allied shows connected with the building services industry, all at one location. Our chapters organize several other popular events like AgriConf in Delhi, Raycon in Kolkata, Symposia in Mumbai, TechFest in Goa, and many more. We are committed to provide training and career guidance to our student members through seminars, lectures, quiz contests and site visits. A-Quest, a prestigious quiz competition organized by ISHRAE to catalyze the transformation of the budding engineering professionals. ISHRAE provides a platform to potential employers to select student members for careers in HVAC and our industry at the ISHRAE Job Junction. Young minds are made aware of the need for saving power, clean air and sustainability. The K-12 initiative of ISHRAE focuses attention on school students' development to inculcate a scientific fervor and help develop them into responsible citizens. Speedy information is imperative to keep moving forward in this hyper-connected digital age. Searcher, a specifically designed search engine, is now available, which allows access to a well-catalogued database on HVACR and building services industry with just a few clicks. ISHRAE cooperates with various national and international bodies, industry, governments, academia, think tanks to promote the concept of sustainability, environmental protection and energy efficiency and conservation to enter and explore the universe of the Indian HVACR industry. Log on to ISHRAE.in that unfolds a panorama of information. Let us engineer a sustainable future together through ISHRAE.
We are 75F. We aren't just making people more comfortable, we're making them safer. We aren't just cutting costs, we're cutting carbon footprint. We aren't just trying to change the world, we're building a better one. Our customers choose a full stack solution of hardware and software that works out of the box, with smart sensors and controls that bring unparalleled indoor air quality and industry-leading energy efficiency to more businesses in more places than ever before. Our supporters include some of the biggest names in energy and technology. And with offices in the US, India, and Singapore, we've built a new automation platform that is more open, more scalable, and more connected. We are 75F, the future of control, today.
So, thank you and good evening, everyone. And we're thankful to you for joining this program. I'm very happy that today we have amazing panel, including amazing speaker for the day. And time has come to know about IoT-based BMS way ahead in a building automation league. This program is organized by Delhi chapter of ISHRAE, sponsored by 75F. So we have amazing panel for the day with Samsay Singh sir, Silpa Sri Basappa, and Kan Chaudhary Chaturvedi sir, along with Brish Srivastava sir with ISHRAE side, Valivla Sidki sir, program chair from ISHRAE side, Syed Hadayat Ali sir, and Sumit Nawate, and of course our moderator for the day, Shiva Siddiqui ma'am. So going forward, I request Brish Srivastava sir to introduce speaker for the day, all three speakers for the day. Before that, I'd like to say here that there will be a quiz contest also, and this is going to create some awareness as well. This is the theme for the day regarding this topic, IoT-based BMS, way ahead in a building automation league. So you are requested to send your question in Q&A section. We'll take it after the session. All the speakers will take it one by one. And you can raise your hand to direct interact with the speaker, or you can ask the presenter directly in this panel. So you can raise your hand, we will allow you to speak after the session. So going forward, over to you, Mr. Srivastava, sir. Thank you.
Hi all, very good evening. My name is Brush Srivastav, CWC Delhi chapter of ISHRAE. Currently, I'm working as a manager sales north for Klima Veneta. It's a group company of Mitsubishi Electric. And I have almost 13 years of experience with the chiller sales. So today we are again at Delhi chapter of ISHRAE learning platform for an interesting knowledge sharing workshop on IoT based building management system sponsored by 75F. So as I am associated with the chiller particular equipment since last 12-13 years, so I know how BMS chiller plant manager are very having importance on building sites. So in current scenario where a lot of smart city, smart building project is coming, where definitely IoT based BMS will maximize the energy savings, including all services, whether it is HVAC, electrical or plumbing. So for today, we would like to thank 75F for sharing this informative synopsis on this particular topic. Thanks to DCI entire team and all our partner who are regularly associated with DCI for this kind of knowledge sharing workshop and sessions. For today's workshop, we have very experienced, prominent speaker from 75F. I would like to introduce to start with Mr. Samsher Singh. He is a regional manager, North and East. He has worked previously with Siemens as a sales manager for North India. Prior to that, he has also worked with Tyco and Honeywell in various roles as engineer. Then Miss Silpa Sari Basapa, she is a product development leader. She has 18 years of very rich experience with a blend of technical expertise, people and leadership skills. Then we have today Mr. Karn Chaturvedi. He is a technical DGM from 75F site. He has worked previously at as a senior lead MEP for WeWork Pacific and India office as well. So welcome all for this particular knowledge sharing workshop, and thank you 75F entire team. So over to Ms. Shiva Siddiqui for moderating this entire session, and thank you.
Yeah, hello everyone. Thank you, Tabas, and thank you, Brij Mohanji, for the kind introduction. So I'll just quickly have a delightful good afternoon, and thank you everyone for finding time and joining us for this webinar. Myself, Shiva Siddiqui. I look after BD and channel sales for 75F, and it's my proud privilege to welcome you all on behalf of 75F to this webinar on IoT-based BMS, a way ahead in building automation leak and energy saving. I would like to extend my sincere thanks to ISHRAE to provide us the opportunity to share this knowledge sharing session at this platform with the industry key stakeholders on the mentioned topic, which is IoT technology. So since Tapas has already mentioned all the rules and for this webinar, so I'll just quickly have a quick run. So I will quickly go through some points to note so we all have a seamless webinar experience. So a quiz will be launched during the short breaks in this session. So you all are requested to please do participate in the quiz. There will be objective questions with the single answers only. And at the end of the webinar, result will be announced and top 20 winners will be awarded with exciting gifts. And finally, we will leave time for question and answer session at the end of the session, wherein we would be happy to take your queries and relevant topics. However, you can raise or type your questions in the chat box. We will be happy to take your questions. So folks, without taking much time, I would like to welcome Shilpa. So Shilpa has very well already introduced by Mr. Braj Mohanji. So Shilpa is requested to please come and start with our presentation. So Shilpa, over to you.
Hello, everyone. Very good evening. It's really great to be amongst all of you and get this opportunity to share some knowledge and insights that we have as we've been working on IoT BMS in the last few years. Hopefully all of you can see my screen.
Can you share it again, ma'am?
Hopefully all of you can see it now.
Yes, ma'am.
Yeah, so today what I'll be covering is I'll be covering a little bit on the overarching architectures that we have had in the BMS space from our traditional to what we have evolved into with IoT BMS. And I'll also speaking about what the data evolution has been in BMS. Please feel free to raise questions in the comment section. If they are in the topic I am in, I'll ensure that I'll answer them. So what in the session, what I'll be covering is basically what is an IoT-based BMS. We'll cover what traditional BMSs have been and how the traditional BMSs has evolved with times as IoT has come in, what it has really tried to do with adding on layers and how native IoT is actually making things better in this space. We'll also go through some data evolution points and how actually to move towards scalable analytics with the data evolution that we are seeing in this space. So if you see traditional BMS workstations, we have different layers. We have sensor and actuator level. We have automation system where we basically have systems which is configured. Then we have integration level and management level. So all of these systems, when it is talking over protocols like BACnet, what happens is they are stuck to their silo. The data is available in only one format until we have various OEMs and their manufactured equipment talking over BACnet. You have really difficult integration that is pending ahead of us. So we do not have systems that is all correlatable. And the only way to do that is follow specific protocols, and that itself has data visibility and data integration constraints. Now, if you break this down into a typical BMS hierarchical architecture, we see field devices. Now, what does field devices really entitle? We have all sensors or equipment which are basically just supplying the information. We have dumb devices like dampers. These are all speaking to some kind of controllers. It could be valve controllers, which we have, which is connected to the dampers here. And we also have generic field controllers, which take in data from these field devices, and they communicate to the next level of data, which is basically global automation layer. This automation layer, typically we can take examples of systems like Niagara, which basically does some part of sequencing across these devices, and it connects over Ethernet and it communicates. If you see in this diagram, we have basically, there are blue lines across. So these are basically bus architecture based comms across these equipments, which will help for transfer of data from the below layer to the top layer. Now, all of these global automation systems are connected to one supervisor, which is usually on-site, and which allows us to do management and control and limited monitoring of these equipment that is already there in a space. As the evolution of these BMS happened and automation came in, there's some amount of client server kind of architectures that has come into place. And we have a concept of supervisor, which is coming, which will allow me to monitor supervisors across the buildings. So basically this is over, this will use BACnet over VPN. Now, if I see the evolution of how these traditional BMS has moved forward, we have a little bit more complex systems that is coming. They are integrated systems which already have sensors in them, which already has controllers inside them. They're communicating to space like a system like Niagara, and this communicates to a supervisor, and that in turn communicates to a supervisor of supervisor. So that is the evolution in the BMS space that has happened over the last few decades. Now, in the last decade or so, what did we actually see? We saw that IoT came into space. We have various sensors that is coming. We have a lot of things that is available in the cloud. So what was the next evolution that happened for BMS is that we introduced the concept of actually having a cloud-based supervisor, which takes in data from all the supervisors across buildings And all the detailing, the sequencing, this happens over a cloud, IoT cloud that is there. So this is the evolution that has happened over time. But what we have really done here is we have taken the traditional BMS system and we have added a new layer on top of it, because we are trying to accommodate the advancing technology that is there, and we want to bring in the ease of use this technology is bringing us. So that is the evolution that we have done in this space. Now, as IoT cloud took importance, there is also a parallel approach that can be done where IoT sensors came in, and if they can actually pump in data into the cloud as well, that adds an additional layer for us to bring in data into the system. It gives things like IAQ control, IAQ management to the people who are in the field who want to monitor. So we have moved from not just adding IoT cloud based approach, but we have moved towards IoT sensor overlay that is getting integrated into the system. So this has been the evolution in the last few decades. Now, the issue with all of this is we have actually made the existing BMS system more complex, because we are trying to accommodate the advancements in technology that is happening. And the BMS space itself is not moving at the speed the technology is evolving currently outside. So we are trying to integrate both of these fields together and try to make the best of it. So when we are trying to do this, what really happens is the data that these systems are generating is siloed. So basically they are in their own space with less interoperability coming into picture. So as we move towards a system which is not just traditionally built, but towards a system that is more IoT based, we are basically not having 5 to 6 layers of what the traditional system has, but the aim is that we collapse it and make it much simpler, much approachable to the people in the field. So that is where the native IoT BMS systems come into place. So if you see here, this is a collapsed layering system from what we saw previously. We have sensors and actuators, we have even the dumb equipment. These communicate to the field nodes or stats, and all of this through a wireless network, they communicate to a on-field controller. This in turn communicates to the cloud, and because of this cloud integration, we have remote control possible through portals and apps. So all of this is much more advanced and more compact than what the traditional system gives us. So that is how the evolution and movement has been. So if you really typically take an architecture of this system, it's quite complex, because now we are going into cloud-based architectures. We have microservices-based distributed system. We have a mesh of microservices and its stack that is available for all the capabilities that we are foreseeing the system to have. So we have moved from a siloed traditional BMS to an IoT-based BMS, which is more compact, but the architecture which is supporting itself is complex, that it allows us to do a lot of integrations, data interoperability. It is the end user is going to find it much more easier to understand, do the control sequences, configure, and move ahead with that. So that is where the movement and evolution has been. So if you see, I mean, this is just a quick comparison across all the 4 types of architectures that we have seen right now. In traditional BMS, we do not really have a digital twin. In cloud supervisor and IoT sensor overlay kind of approach, we have a moderate way of actually doing a digital twin of a particular equipment or a particular space. Now, all of you, if you are wondering what is a digital twin, I'll cover that in the next part of my session. But this is the evolution. The native IoT BMS that is there for us actually will allow us to not only do digital twinning, it will allow us to do energy efficient algorithms, over the air upgrades. It's going to allow us to monitor a lot of historical trending data. It's going to ensure that the sensor data that is really integrated, there is richness in whatever is coming from the edge sensors or actuators into the system. We'll be able to really monitor them as is. And we will have the option to introduce machine learning and AI into this whole mix. So that is what a native IoT BMS is going to enable us to do. So now we spoke about what the architecture has been, how it has been deployed across the buildings. Now, if you think about it, after deploying all of this, all our buildings are extremely dynamic. Each building has its own variation. Each building has its own dynamic nature of how it really is represented in the digital world. So for each of this building to be really understood, what really starts making more sense in the next step of evolution is that it needs to be highly communicative. If it needs to be highly communicative, the base that comes into being is that its data needs to be really robust and understandable to any system that it gets integrated in. It could be as simple as we have a OEM that is installed in a building. Another OEM coming into the system should be able to easily integrate it with a OEM equipment that is already installed and work towards an integrated dashboarding system. So that is how the future of building management needs to evolve for all of us to benefit from it. So now going back to a little bit towards what was our data, I'm going to speak about the data part of it. So in the 1970s, I think Modbus has come into the picture. We saw a lot of systems that has a Modbus-based dataset exposure. So what it really exposed is, it exposed the properties and it exposed it in a register format. It said if it's a read or a write, and it specified the units, in what scaling format it is, and what is the range or a enumeration that it needs to take on. So ideally, for me to understand this on an equipment, each person needs to have access to the manual for that equipment. If there was an upgrade done to the equipment, then I had to really have an access to the upgraded manual. If I had a previous manual and my equipment had a different version of Modbus exposure that was exposed, then I would have found errors, or even while configuring and reading it, there would be a lot of mismatches that we need to figure out and find out which version is mapping to which manual, and I need to go back and read. So this is how the data was with respect to Modbus. Now, after a decade or so, we got into the BACnet data format. BACnet data was more evolved. It was a protocol that allowed various systems to really follow and exchange data. So what it allowed is, along with this, it allowed the equipments to be discovered, and it allowed to self-proclaim all the data the equipment exposes and all the properties that is associated with it. So the evolution was from having a user to read a manual, we evolved into a practice where the equipment was self-aware, and systems that are reading it, they had properties that were exposed. So this part of the evolution, I mean, that is pretty advanced. We moved from a simple system to a more advanced, more interactive communicative system. But with BACnet comes the complexity and the version that we need to support, or if there are systems that are integrated. If there's a system that is integrated with one version of equipment, and later that equipment, the data type has got changed. When the rediscovery and integration happens, it all needs to be redone again. So that is the complexity that came into the system with this evolution. So moving forward with IoT coming into space, we have gigabytes of data that is getting pumped into the cloud every minute from all sensors, from all equipment. Now, these gigabytes of data that is coming into the whole of the cloud needs to really be meaningful for us to make sense out of it. So the next step of evolution is all this data that is coming in from millions of devices, sensors that is put into buildings, and all these millions of data points that is coming in every minute of every day needs to be really analyzed, made, I mean, the user needs to perceive what the data is coming in as. And if it is from only one equipment, then again, we are curtailed by the interoperability part. So that allows us to see how the IoT in the BMS space has really moved forward. This allows, I mean, if I configure a particular building in a certain way, and I do the same configuration, a similar configuration for another building, then the data that is there and which is consistent across these multiple buildings, if it is easily understandable, we can evolve a system that we can also expose it to others, because the tagging system would be same, and even other systems can easily understand. So there comes the point of a digital twin. Now, if we are able to give an out of the box digital twin for each equipment and the configuration that we do when we install in a particular building, that itself gives us a lot of data and clarity on how the data for a particular building is. So this ensures that there is interoperability across buildings because they have a very similar digital twin for a particular equipment across. If the data modeling for each of this is very similar, then what happens is the machine-to-machine interoperability between two kind of equipments that are installed in a building becomes very seamless. So we moved from reading manuals to we are moving towards a space where each machine can speak to the other machine and just exchange data very seamlessly without having a lot of people coming in and system integrators coming in and doing manual mapping and trying to understand which system means what in the other system when you map, and if you can build analytics very clearly and easily. So if we really want a digital twin to work in this space, what we really need is we need a consistent data representation. So it needs to be a domain model or a template that is really understood by various equipments across. It requires for tagging of out-of-box sequences so that the tagging is easily understandable and shared across whenever a domain model is shared. And this also helps us build a pre-packaged analytics. And this can be made more robust because many equipments are having the same data structure and data formats. So I'm going to give you a small example of that. So what that basically means is the data that we are getting in needs to be highly informative, easily customizable, and it needs to be actionable for us to do further analytics on that. So if we have pre-packaged analytics that is there, where it is going to give facility managers and other folks associated with the buildings to easily monitor and make sense of the data that is coming from all the IoT equipment, along with option to integrate with other systems and have pre-packaged analytics. We have already solved the problem of multiple systems can coexist within a building space. So one of the examples here is I've taken examples of project haystack tagging. So if we have, if you see this system, this is just a sample of, for one building, we may have as many as 24,243 data points. This is a fairly large, decent sized building. So we may have data in this range. And if, let's say, across zones, across spaces, we have hundreds of sensors that is put in, just using a tagging system and querying with humidity. This is a humidity value. If I just query a humidity-based search criteria, then all my humidity sensors in that space comes in. Then the user can compare all the humidity values across and take a decision regarding if he needs to go revisit, change the set points for the humidity in a space, and what he really needs to take action on. So this is just an example on how data tagging and data interoperability can become common across different equipments. So if there's any questions. Atul, please go ahead if you have a question.
Yes, Atul, you can please speak now. We can see your raised hand.
You can type in the questions as well, Atul, if you're unable to speak. So, Shiba, we can wait for his question. If it comes up, we can definitely answer it later on. I think you can continue.
So one question is there in chat box. I can see here. Would you please introduce any references for the basics of IoT-based BMS?
So the various systems, I do not really want to take a company name. The various systems that are currently available, the various systems that are also layered are existing traditional BMS with IoT cloud and IoT layering with sensors and additional things. So all of these systems currently exist. So I mean, this is basically the equipment which gives complete stack solution from having sensors, hardware installation to a software analytics and cloud-based solutioning and monitoring. So I see Kamal is asking about digital twin. So if Kamal, if I really need to define digital twin is basically any digital or web-based representation of a physical building or a system or an equipment. So basically what it does by doing a digital twinning is that it allows me to monitor the whole building in its holistic format, because I know what all properties are associated with the building. Or if I say there's a digital twin for a valve system, I know all the properties that I'm interested to know for a valve system. So the digital twin will easily provide clarity on how you really monitor its properties. You can plot them if you have custom visualization very easily, and you can monitor them closely. Let's say you're really bothered about CO2 level in a particular space. So, and this is a property of a particular node that you have deployed in that zone. So if you know this is a property of a node that is there because this has a sensor and input is coming in, you can build your analytics on top of it. And you can monitor that. Okay, Atul, I think you're saying that, are you comparing live building performance in digital twin, building energy calibration or something like that? Okay, I think Karan is opting to answer that live. So I'm going to allow that for Karan to take.
Atul, I would ask you to have some patience. I have perfectly something which will address this point.
So Atul will readdress this after Karan's part of the presentation. Okay, if no further questions, I'm going to hand it over to Shiba. Thanks, everyone.
Yeah, no further question from Shilpa. Shilpa, thank you very much for sharing your knowledge with us on IoT. It was indeed very insightful.
Thank you
so much. Yeah. So folks, prior to move ahead with our next presenter, let's have a first round of quiz. Quiz, please. Looking forward to anyone, please participate. It's a single answer questions only. And top 20 will be getting exciting goodies as well. Even it can be extended if more participants are there. Okay, so I think enough time has been assigned to answer these 4 questions. So moving forward, I would request Kern to please take the session forward and enlighten us with your knowledge on IoT. So Kern, over to you, please.
Great. Thank you, Shiba, for the introduction. I'm going to start sharing my screen. Yep. Thank you. Okay. I'm going to assume that my screen is visible and I'm going to get started. So I would first like to thank Shilpa for giving us a very good theoretical background on what is IoT and what is the application of IoT in BMS. I would like to cover more in terms of what are the real world applications of IoT, as well as hardwares which are related to IoT. So a little bit about me. I have spent, I think, since 2014, one way or the other, I have been dealing with IoT systems. It started with my stint as a research engineer in NUS in the Building Energy Efficiency Group, and then as a lead MEP for WeWork Pacific as well as WeWork India, and now as technical DGM for 75F. So I have been thinking and working a lot on HVAC applications of IoT as a technology, right? So I have a couple of thoughts I would like to share on that. Briefly, this is the agenda that we would like to cover. A bit of a motivation of why we want to study all of this, understand the hardware components, and we look at a couple of applications which are possible with IoT BMS. So this is something that you would have noticed when you are specifying buildings for your clients. There is a shift in the expectations that clients have from their buildings. So now, because the new generation of workforce which is coming in, they are coming in with a strong sense of environmental responsibility. People actually care about carbon footprint, energy efficiency. You would actively see people complaining that, okay, this light, this street lights or these hallway lights, they are on when they are not required. Please switch them off. We are needlessly wasting energy, right? So there is a certain shift in the expectations that folks have for what their building should do. At the same time, people who are actually specifying and operating these buildings, their demands have also increased, mainly because of rising energy cost, which we have seen due to the recent geopolitical pressures that we are facing. There is an increased need for doing more with less. At the same time, while folks are doing all of this, it has become very important, not just for the building, but for the organization, to communicate what steps they are taking to address the environmental concerns as well as the bottom line concerns, right? So increasingly, because of all of these aspects, we are seeing that building performance is now impacting business performance more and more. So there is a very strong need for communication between what is happening in the building and how it is impacting your businesses. Now, normally for all of these requirements, one would turn to BMS, right? Because that is what is connected to all the sensor. That is the system which is controlling all the data. It is the gatekeeper of the data, and that is the interface that your building manager has with the building systems. But there are loads of limitations with the traditional BMS, and some of these might ring very true to you. Firstly, there is no inherent energy savings promise that comes with a BMS, meaning that certainly by scheduling and operating with the control sequences, you are guaranteed to save some money. But how much is that? And how is it being monitored, right? And it's become very important because a lot of the energy is consumed by commercial buildings, right? And if we look at the energy consumption of commercial buildings, they would be probably the first or the second most, the largest contributor of greenhouse gases in the world. And especially in buildings, 70% of that would be utilized either for cooling or for lighting. At the same time, because these buildings are occupied by various occupants, they have different expectations for what their thermal or lighting or acoustic comfort would be. And many times these are not properly met by BMS. I mean, there are tools to do it, but it has been noted that the satisfaction with the temperature levels, especially if we increase the time post commissioning, it keeps on diverging from what the expectation is. Also, for many BMS systems, there is a knowledge which is stored with a good BMS operator who understands the various peculiarities of the building, right? And once that person goes away, he takes that knowledge away with him. So those peculiarities of the buildings or those adjustments, they are not properly transferred to the next person who comes in. So while one can argue that these are automated systems, but they are actually operated by the operator, and they are quite dependent on the skill level of the operator. At the same time, and I think this is, for me, one of the largest issues, we as consulting engineers, we do specify a lot of points, a lot of alarms, a lot of trends, which are all captured in the BMS system. But over time, the knowledge of these trend points, the knowledge of these alert points goes away. And when the client comes back and asks us, like, hey, I wanted all of these features, where they are, you have to point them back to it. Like, no, it's there in this. And then if they want to get that data out, they have to do it manually using Excel sheets or thumb drives or internet file transfer, which is not very immediate, I would say. So these are, broadly speaking, the limitations that we see with traditional BMS, which seems to be not quite satisfying what is required from the modern building. So the solution for that is to have not just a IoT BMS system, but a building intelligence system, which is looking at all of these points, mainly energy saving, so that you can show your bottom line, maintenance of comfort, as well as communication of all of these data points with the user and the operator. And this requires a combination of hardware, software, cloud analytics, and even machine learning or artificial intelligence application. So it's a different architecture which needs to be deployed compared to traditional BMS. And if you look at the unique advantages that a building intelligence system based on IoT can provide, firstly, because it is IoT, a lot of these devices and sensors are wireless, so they are easier to install, they are easy to scale. You don't have to do a lot of wiring. You can install them pre-installation or maybe post-installation. If you realize that, okay, I need more data, you can just install these and they'll start to communicate wirelessly. Because all of the data is collected by IoT systems on a cloud-based platform, so it's easy to query all of that data and show it in a easy to visualize way anywhere using an internet connectivity. Also, because all of this data is collected and it's really rich data, you can utilize that data to run some artificial intelligence or machine learning algorithms to derive more value from the data. And of course, because of all of these features, there is a high ROI which can be expected from such a system. Without further ado, I would like to get into what the architecture of a system, especially hardware architecture, should be. Right. So I have a typical building, and it shows the hierarchy of what all of these systems are. We'll start with the bottommost rung, which is the most important. These are the on-field sensors. These sensors are more or less the eyes and ears of the BMS systems. They actually capture all of the data, and based on this data, everything else can happen. So it is very important that this data has to be very accurate, right? And it has to be very usable, and there has to be a certain frequency at which you're receiving this data. If we are able to have these sensors which are integrated, that would be even better. So the sensor data should not just be restricted to temperature or humidity, but other factors as well, which impact occupants. So CO2 levels, VOC levels, both of which are shown to have very high correlation with occupant performance, light levels, occupancy levels. All of this data, if it is collected through integrated sensors, that would make it very easy. At the same time, there should be an expectation that these sensors are quite accurate and they maintain their accuracy over a longer period of time. So ideally, if they have some auto calibration sequences, that would be very useful, because then we can be sure that over time, the data which is coming in from all of these sensors is actually reliable, right? So this is the first rung. The second rung would be the communication nodes. So because these sensors are collecting the data, they have to be communicated to the main central system. So you would need some communication nodes. So you can think of these like your Wi-Fi routers, which are installed everywhere, which means that any data through Wi-Fi that can be communicated can go from one router to the other router to the internet, right? So these communication nodes can be dedicated communication nodes, or more usefully, these communication nodes can have an inbuilt network creation capability, meaning that these nodes can actually create their own network and at the same time can act as a simple controller for simple devices. So for controlling some dampers, for some valves, for running simple PI loops, it can be done, because the IO points for simple devices are all very similar. It's just that which type of device it is will dictate what the control sequence is. So you can utilize similar IO points to control various type of devices, and all you have to do is swap the control logic, right? So this would be the other component, which would be a communication device along with a simple control. Now, there should also be an aggregator, which is collecting all of the data from all of the on-field sensors and control devices. And this aggregator should be a central aggregator, which is controlling the central plant. So in the field, it can be your AHU, or it can be something like a VRF system, right? Or maybe even some third-party devices such as PSCs, fire alarm systems, NOVAC systems, UPS system. And this device should be able to not just collect data, but also communicate it to the cloud system, where it can act like a broker of data between what data needs to be stored on the tablet and what data needs to be stored to the cloud, right? And of course, the final component would be a dashboard or a web portal, where you can see all of the data which is collected, not in terms of a trend, which is just a straight line, or not in terms of an Excel sheet, but in terms of how the user want to actually see the data, or in what format the user can actually extract insights from the data. And at the same time, you do want the user to give some control. So much like most things in our life, there should be an app to interact with the system, or even just send some information to the system. So a user app would be a useful component here. And at the same time, while all of this data is related to the building, there should be an avenue for this data to be communicated to other devices. So as Shilpa was mentioning, the previous protocols which were utilized for buildings like Modbus or BACnet, they are very specific to the buildings. Modern softwares, modern apps, they don't really speak that language. So there should be some way for this data to be accessible to modern apps or modern control systems. If you have an enterprise control system, there should be an avenue for exchange of data, which can be understood by both the parties. So APIs are the most popular way these days. So certain level of API integration availability would be very useful. Right. Now that I have spoken about components, I would like to spend some time talking about a couple of applications which are possible with a building intelligence system, or rather, these applications are easier to apply thanks to a building intelligence system compared to a traditional BMS, right? So first of all, I would like to speak about advanced control sequences. So all of the professional bodies are also realizing that this change is coming in and disrupting the industry. So they're also coming up with control sequences which can be specified for IoT enabled devices. So there is one such control sequence or one such guideline which is proposed by ISHRAE called ISHRAE GPC 36. And in that, you would notice that they have a requirement for zone level CO2 set point and zone level CO2 control. And providing that with traditional BMS is going to be very challenging because in a particular system, you would have multiple zones, and provision of multiple zones will require a lot more IO points and a lot more wiring. But providing this with a wireless IoT BMS would be way easier, and not just providing the sensor and providing the data, but also communication of this data and also application of this data would be way easier, right? Because these control sequence, they are no longer limited to, let's say, controlling based on, for example, a group of static set points or return or supplier temperature. They actually want input coming in from various zones. And based on the input coming in from various zones, they want to have the system respond to that in an aggregated manner. So the expectation is that your control sequence should also be able to parse and apply a whole lot of data and control accordingly. At the same time, these advanced control sequences are also built in for providing inbuilt energy savings. So I'm not sure if you're able to see the screen over here. On the left side, we have a table. This table has been received from Building Controls Authority Singapore, and they have a standard called Green Mark, which is similar to LEED. So they have been observing the VAB systems which are installed for Green Mark, and they have observed that for various levels of VFD percentage, how much energy is being consumed, right, for Green Mark buildings. So these are basically your top of the line energy efficient buildings, right? And they have compared it to over here in blue, the values which were actually extracted from an IoT BMS, which is applying a version of control sequence similar to ISHRAE 36. And what was observed was that the energy consumption of the NRB 2015 was actually quite high compared to the energy consumption of an IoT BMS with GPC 36 control sequences. So I want to highlight this because this orange line over here actually represents the VAV performance of very sustainable buildings. So these are not your normal buildings. These are buildings which have gotten a green mark rating from Building Controls Authority Singapore. So compared to those top of the line buildings, there is still avenue to save energy using IoT BMS. And this has been accepted by the authority as well. And they are encouraging folks to start using these systems and utilize these values in their control sequences and energy modeling as well. Also, because of these IoT BMS, because we are able to pack more sensors in any given space, we are not only able to provide a lot of input, but we are also able to utilize that input to provide better control, right? So, and that is mainly for providing enhanced comfort. And the reason for that is that instead of just relying on zone level temperatures, with IoT sensors, you can actually get much more data. So it can be not just your temperature, it can be relative humidity, it can be your radiant heat, it can be even your acoustic performance, and all of these inputs can be utilized to provide more comfort. So you can see on the graph over here, by taking in all of this data and utilizing these advanced control sequences, we are able to control the temperature levels at a closer band, right? And that is possible with the IoT BMS system. And the most important part of this table over here is that compared to a normal mode of a normal control sequence, the temperature adherence is much better with IoT BMS. So this additional comfort is not provided just this additional comfort is not provided at the expense of energy savings. In fact, what can be noticed over here is that in the case of WeWork, where an IoT BMS was deployed from for 2 months, July and August, it was noted that more energy was saved, right? And at the same time, the number of complaints which were brought up, comfort complaints, actually came down. And you can see in the background over here, green represents adherence to the set point between 1.5 plus or minus 1.5 degrees. And in a co-working space like WeWork, you can see that all of the various zones, they are within 1.5 degrees of each other, of the set point. And loads of spaces would have different set points. And even then, we are able to provide the cooling using the IoT BMS in a much better way. The other example or the other advantage is that getting visibility on your portfolio of buildings becomes way easier. And there are a couple of examples of that. And it becomes easier mainly because IoT BMSs can be more scalable. They can be deployed on a small space or a larger space. And because they are directly communicating to the cloud, you don't have to worry about any data storage requirements or data communication requirements. And it's easy to deploy them at scale. For deploying 10, you can just account for 10 software points, or if you are deploying 100 sensors, you can just account for 100 software points. So there is no requirement for, so to speak, an infrastructure or license planning with IoT BMS, which makes it very easy to scale, so that as and when new buildings are coming online, all of these systems can be provided with an IoT BMS system, and the data starts to come online. And as the data starts to come online, it is possible to customize the data in dashboards that focus on what is most important to the clients. So for the dashboard on the left, it is very clear that thermal comfort and CO2 levels are very important to the client, as well as the breakup of energy, right? And for the dashboard on right, the breakup of energy is important, as well as comparison of the energy consumed between various sites, right? Along with daily energy consumption, or both for electrical and BTU data, as well as comparison between an energy benchmark and what is actually being consumed. So it makes it very easy for us to slice and dice the data and show it this way. Now, by doing so, it is actually possible to save a lot of energy. One such case study would be for home furniture, where they had deployed an IoT BMS for a bunch of their outlets. So you can think of home furniture as a furniture outlet, something like IKEA, but smaller. And this is mostly in the US. So in the US, you would have various strip malls and locations where these outlets are. And by installing an IoT BMS system, home furniture noticed that they had visibility on all of the energy consumption. And by installing such a system, they were able to bring down their energy consumption by quite a bit, by almost 20%. Now, certain gentlemen, I think Mr. Atul had asked about predictive analytics. Basically, if I can remember the question correctly, it was about digital twin and the application of digital twin in energy modeling. So this is a great example over here for IoT capability of IoT BMS. So because of the granularity of the data which is collected from IoT BMS, it is possible to do a lot of analytics on top using machine learning and AI algorithm, where we can identify what are the components which are having the highest impact. And based on that, it is possible to create a model, an energy model of the consumption of the building. So we have over here data which was received from a building where it was identified that the two components which had a lot of impact on energy consumption for this particular building was the occupancy level and operating hours. And one could see that the yellow bars are representing the occupancy and the green bar is representing operating hours. And you can see that as both of these numbers are rising up, the orange line over here, which represents HVAC consumption, is also increasing, right? Now, by creating a digital twin of this, we understand how the energy performance of this building would be as these factors change. And we can predict that by this baseline green line, right? And this baseline green line, if you notice, is following the increase in the yellow and green bars. So as yellow and green bars are increasing, right, your green baseline is also increasing. And after a while, it stays more or less the same, right? Now, using the digital twin technology, we are able to create this baseline and verify, excuse me. Yes, so we are able to create this baseline and we are then able to compare it with the impact of installing IoT BMS based control sequences and see how much energy was saved, right? So this basically allows us to create a digital twin model of the state of the building before intervention and state of the building after intervention, where we can start to identify where the energy savings are, right? And this can also help you predict the energy performance based on various factors and compare it with the actual consumption and update your models. So these were a couple of applications which I had. I see that there are some questions on the screen. Please feel free to add more questions while I answer these questions. I'll be happy to take any questions right now. Maybe moderators can help.
Should I read, sir? One question is there: how we can connect traditional BMS to IoT for advancement? Is there a little bit physical modification required, or need to completely replace the system or DDC and sensor devices?
That's a great question. Uh, so there are actually systems which are available in the market, mostly IoT sensors, which can communicate with the traditional BMS. That can help you solve some of the issues, certainly. But if we want to have the full advantages of IoT BMS, it is important that we install a native IoT BMS. And the advantage of that is because once we install the native IoT BMS, the way the data is being captured, right, it becomes uniform, right? Which means that all of that data which is being collected from the site can be uniformly applied and can be uniformly collected and can be uniformly displayed. So I'll give you an example. Let's say you have a brand X traditional BMS, and then you connect your IoT sensors from brand Y. So you would still have to bring in the commissioning engineers from brand X. Please commission these sensors, and all of that data still stays in the same building. So if you want to take the advantage of cloud computing, machine learning, predictive analytics, that won't be possible because your data is still limited to the brand X BMS. I hope that answers the question.
Okay. Thank you, Karan. So I can see some more questions over here. The first one is, in case of lost internet connect, it means lost the communication.
Not really. The data is actually stored at various nodes and aggregators. So if I can just show a couple of my slides over here. So in this architecture, we have this IoT controller and gateway, right? So this acts as a broker between the data collected on the building and data which is sent to the cloud using internet, right? So all of the data, let's say there is loss of internet connectivity, the data would be stored over here until, let's say, after a while, internet connectivity is restored, and then all of the data can start to communicate with the cloud.
Okay. And the next question is, you talk of auto calibration data collector sensor. What take on cost?
I think the question over here is what would be the additional cost of auto calibration of data collection over sensor. So you would have to find these auto calibrated sensors in the market. So it really depends on how these sensors are integrated with the system. So there are various makes and models for those. You can find them on pretty comparable cost to your traditional sensors as well.
I think somebody from Delhi chapter of ISHRAE wants to answer this question. No? Anyways. Next question is, what are IoT techniques like AI, ML used in the cloud?
Excellent question. I like this question because a lot of folks always talk about IoT and ML algorithms, but they don't really talk about what are these IoT and ML algorithms doing in the cloud. So broadly speaking, there are a couple of things which can be done. Firstly, IoT and ML can be used to create an energy model of your building, right? So basically, you can start to correlate changes in temperature, changes in set point, changes in your inlet and outlet chill water temperature, or even changes in weather to changes in the HVAC energy consumption. And once you collect a lot of that data, a model can be created in the cloud, right? So your system starts to anticipate, right? So I can give an example of this. Let's say every Wednesday there is a meeting, lunch meeting in a meeting room, right? And they always order pizza for 12 people. So the system over time would learn that, okay, on Wednesday lunchtime, I can expect a lot of heat load in this meeting room, right? So it can start to pre-cool the meeting room in order to make sure that when all of those 12 people move in with their pizzas, there is plenty of cooling provided. You can also have a correlation with, let's say, temperature. So, for example, normally when you're building startup, it has a lot of energy or heat stored in the structure of the building. So it takes time. So it would normally consume more energy then. However, if by machine learning and by weather forecast, we know that it is going to be a cloudy day. So machine learning algorithm can actually temper the amount of cooling which is provided and help to save energy over there. So these are a couple of examples. There are other examples in predictive maintenance and alerting, which are also there. I think we can discuss that in more detail later in some other session.
Right. So we have one more question from Mr. Kamal Murli Kumarji. How analytics reduces the energy?
Excellent question. I can give you an example. I think. Okay. So if you remember, I will just go back to my last slide over here. Yes. So we have created an energy model over here, right, using IOT BMS. Now, this energy model will predict if there are no changes, what should be the energy consumption, right? Now, if over time, let's say you start to see your energy consumption rise, and then you notice that your other factors over here, for example, occupancy, operating hours, or your ambient temperatures, they're not actually changing so much. So because we are looking at this data, right, predictive analytics can start to come in and raise a flag that there is actually an increase in energy consumption, which is not corresponding to either increase in occupancy or increase in operating hours. So what is it? So it will help us identify that, okay, there might be some other systems. Maybe we should start to look at leakages in ducts or leakages in your chill water valve, or maybe your DP sensor for your secondary pumps, it has lost its calibration, right? So because we are looking at all of this data, we can come up with these predictive analytics to raise a flag and say that, look, guys, we are actually consuming more energy than we should. Let's start focusing on what the reason for that is.
Yeah. And another one is, what are the benefits of IoT for plant maintenance?
I think I answered part of that just now. By looking at predictive analytics, looking at the energy consumption data, we get to know what a normal operation of the plant should be, and we can compare it against a baseline. And if it crosses the baseline by more than, say, 5 or 10%, we know that there is some discrepancy in the plant operation. And we can start to zoom in and look into what the issues are.
Okay, so some more questions are there, but these questions are already, I can see that you have already answered. So any more questions? So no questions now in the chat box. So thank you, Kern, to enlighten us with your knowledge. You really brought very valid pain points, I would say, for any building when it especially comes on HVAC part. I mean, thank you to joining us today, despite you're not feeling well. Okay. Thank you, Karan.
Thank you for having me.
So, folks, moving forward, it's a time to launch second round of our quiz now. So, I would request to web team, please launch the question. everyone please participate. Even those are requested who has joined in middle of the session, they can also, participate in the quiz. So I hope you all have attended by now. Shall we move forward? So now, last but not the least, I would like to call Mr. Shamsher Singh to take this session forward.
I hope you can see. I'll just share my screen. Give me a second.
Yes, Shamsher, we can see you.
Can you hear me? That is more important.
Yes, it is very much
Okay, audible. I'm audible. I'm not being able to share my screen. It says host disabled participant screen sharing.
Please go ahead, sir.
Please.
You can share it now. Please go ahead.
I can share it now. Just give me a second. No, I'm still not being able to share the screen. I'm not being able to share my screen.
Just a minute, sir. Is it fine now?
Looks like, just give me a second. Can you see my screen now?
Please reshare it, sir.
Just give me a second, please. Yeah, I think you can see my screen now.
Yeah, fine it is. Yeah.
All right. Thank you very much. Thank you very much, Shilpa. Thank you very much, Karan, for such insightful sessions. So Shilpa spoke about the theoretical side of IoT. Karan spoke about the application of IoT in HVAC, and those were really very insightful presentations. So to continue, so in my session, I'll talk about the introduction to 75F. I represent 75F. I am a regional manager for North and East India with 75F. So in my presentation, we'll talk about the following subjects. Just give me a second. Looks like my presentation is not moving. Yeah. So this is the agenda of my presentation. We'll talk about who we are. That is a brief introduction to the company, our investor profile, few awards and recognitions that we have won. We'll talk about few of our customers and the results that they've been able to achieve using our solutions. Then we'll talk about the problems that we address, and we'll also talk about few of our technology solutions and a few customer references and how we've been able to help our customers achieve their goals when it comes to energy efficiency. To start with, we have a very small video. I'll just play it. Give me a second.
We aren't just making people more comfortable, we're making them safer. We aren't just cutting costs, we're cutting carbon footprint. We aren't just trying to change the world, we're building a better one.
Sir, voice is not coming. Same video is with me also. Should I share from my side here?
Yeah, please. If the voice is not there, maybe you can share it.
We are 75F. We aren't just making people more comfortable, we're making them safer. We aren't just cutting costs, we're cutting carbon footprint. We aren't just trying to change the world, we're building a better one. Our customers choose a full stack solution of hardware and software that works out of the box, with smart sensors and controls that bring unparalleled indoor air quality and industry-leading energy efficiency to more businesses in more places than ever before. Our supporters include some of the biggest names in energy and technology. And with offices in the US, India, and Singapore, we've built a new automation platform that is more open, more scalable, and more connected. We are 75F, the future of control, today.
Thank you. Thank you for sharing the video. I think I'll have to share my screen once again. So please allow me to do that.
Yeah, please go ahead, sir.
Yeah, I think you can see my screen now. Yeah. Can you hear me? And I hope you can see my screen now.
Yes, sir. Perfect.
Thank you. Thank you. So just to talk about few of our financial backers, few of our investors. We have been funded by and backed by world's biggest names when it comes to energy efficiency and clean technology. So we are an investee company of Breakthrough Energy Ventures, which is a venture fund founded by Bill Gates, and then later on joined by top billionaires like Jack Ma and Jeff Bezos, etc. We have also been invested by Siemens and Oil and Gas Climate Initiative as well. Oil and Gas Climate Initiative is again a venture fund founded by these top oil and gas companies like Shell, Aramco, Reliance, and all. Then there are other investors like Clean Energy Trust, Revolution Ventures. So the idea behind this slide is to just tell you that we have the confidence and the money of few of the world's biggest names. We, as you would know, are a comparatively young company if you compare us against the traditional BMS players like Honeywell, Schneider, Siemens, and Johnson Controls of the world. But in the very short span of time that we've been there, we've been recognized as one of the leading companies, in top 10 BMS companies by Frost & Sullivan in one of their recent surveys. And that's a pretty big pat on our back, and it gives us even more confidence, and it motivates us even more further to keep up the good work that we're doing. A couple of awards that we've won so far, and these keep coming. So the list is pretty large. And again, it shows, it's a testimony to the good work that we're doing. This slide is about a few of the customer references that we have. Top half is US clients, the bottom half is APAC clients. And we talk about APAC clients, these are primarily India clients. So top marquee names like Mercedes-Benz, WeWork, Shell, Mahindra, Flipkart, Netflix. We've done quite a few. Overall, some 300 odd buildings and around 20 million square feet under management so far. And most of these clients these logos that you see here are our repeat clients. So it's not that we have done only one building with them. We have done almost with most of them we have done multiple buildings. That is a testimony to the efficacy and efficiency of our system. We've been able to foster strategic partnerships with global leaders like Daikin and Singapore Power, Daikin in the US and Singapore Power in Singapore. So we'll come to what problems we address. So, and what are the solutions that we have? So what are the areas that we cater to? Our offerings revolve around these 5 areas. Our key and core offering is around HVAC control and air quality. And this is HVAC control for energy savings. So our core solution is around HVAC control and delivering guaranteed energy savings. As Karan was speaking in a session and he said, yes, through the scheduling and all traditional BMSs do deliver savings, but how much savings, and who guarantees it? So we guarantee it. That is the difference between us and a traditional BMS player. Then we have solutions for lighting control and automation. We have some really good solutions around energy management, all your consumption data, graphs, dashboards, all updated in real time and in your customized format. We have solutions around indoor air quality management. Indoor air quality, as you would know, is becoming quite a bit of a concern thanks to COVID. And even if you say, even other than COVID, thanks to the pollution levels that we have. And we have some really good solutions around that. We also can integrate third-party systems like rodent repellent, UPS, water leak detection systems and all. And that makes us a IBMS, in an integrated building management system. So we have that functionality as well. We'll talk about a few of the advantages of our systems. So our system is predictive. As Karan was talking in his session, he gave a very good, nice example of pizza, and people eating pizza at a particular time at a particular day in a conference room, and the system being able to detect it as a pattern and modulate and the system accordingly, and adjust itself for ambient temperature using weather forecast information. So all these features is essentially what makes our system predictive. We save energy. That is our key value proposition. We improve on comfort. So all these energy savings certainly do not come at the cost of comfort. We either maintain the comfort level, or in almost all cases, we actually improve on it. We are very much open to third-party integration. That makes us scalable. It makes us open to all kind of integrations with other systems. We are a wireless system, so that makes us very, very retrofit friendly. It cuts down on installation time, as well as causes minimum disruption to existing operations at an existing facility. As we save energy, so in a way, the system pays for itself. And in almost all our cases, we've been able to achieve ROIs of less than 3 years. In many cases, even 1 and 2 years, but max to max 3 years. So the system has been able to achieve very quick ROIs. So the problems that we address, key problem is that in any building, as you are all aware, you are all from the HVAC industry, so you would know, the HVAC is the largest energy guzzler in any building. Lighting used to be a close second, but then with the advent of all these LEDs and efficient lighting, it is primarily the HVAC. And as you would all agree that a substantial amount of energy is wasted in HVAC. That is where we come in, and we help our clients save substantial amount of energy on HVAC without actually compromising on the comfort, as high as say 30 to 50% on the HVAC consumption. The other problem is that due to the inefficient operations of the current HVAC system, a lot of comfort issues are there that essentially leads to productivity loss of employees. So since we improve on the comfort parallelly, so we also help our clients achieve better productivity with their employees. Other problems like lack of actionable trends and insights, all these are taken care of because our system is native IoT. So all the data is on the cloud. So drawing patterns out of it, graphs and analysis and analytics is just a click away. So how exactly do we do it? We have a full stack, what we call a full stack solution. So we manufacture everything right from the sensors to the platform. So all the sensors, the communication devices, multi-sensors, and controllers, and to the platform. So that allows us to have a better control all across the complete system, and allows us to deliver far better value to our customers as compared to anybody who is having a limited play only on the software side or only on the sensor side, or somewhere in the between. We try and keep complete control over the complete solution. So this is very relevant to what Shilpa was showing. You can compare these traditional BMSs, cloud supervisor systems, and IoT sensor overlay, and native IoT BMS. Native IoT BMS is where 75F solution lies. And on all these parameters, like digital twin, ML optimization, sensor data integrity, and others, you can see that native IoT BMS is the most optimal technology, or the most optimal solution, which provides all these features in full functionality. So the cross here essentially means the feature is not available. The orange tick means it is available, but with limited functionality, limited features. So essentially partially available. And it's only when the green tick is there, it essentially means that the full functionality of that particular feature is available. And if you see in native BMS, which is where our solution is, we have these all full functionality. All these features are available. So what are the few technological solutions that we have? So all these energy savings that we achieve, those are primarily achieved by using two of our proprietary technologies developed in-house by 75F. For the low side, we have something called as dynamic airflow balancing. And so a pictorial depiction of the same is here. Of course, we can discuss it in detail if anybody is interested. And for the high side, we have something called as dynamic chilled water balancing, where the whole principle is to maximize the delta T and ensure that good amount of heat transfer happens. And we reduce overall consumption of the chilled water, and hence as a result, reduce the cost of the energy consumption on the high side. Other solutions that we have and other few applications are outside air optimization, wherein we use the most optimum algorithms to ensure that fresh air intake is used in a most optimum manner, so that both the air quality as well as the energy efficiency of the system is maintained. Then we have solutions for applications for smart VAV controller, as well as indoor air quality management. For indoor air quality management, we have multiple multi-sensors, and which have sensors for CO2, your PM 2.5 level, VOC levels, noise levels, etc. And using those sensors, we can monitor as well as control the indoor air quality parameters like CO2 levels and all. And then comes the platform, which is our core differentiator and strength. This is where all that magic actually happens. So this is our platform from where a client can access his complete facility right on his mobile or a laptop or any internet connected device. He can get to see all the live heat maps of the building, all the graphs, analytics, past data, any kind of analysis or analytics that he wants to run as per his choice is just a click away. We also have an occupant app using which the client can give its employees functionality to set their own temperature and lighting as per their own preferences. So any employee can set the lighting, the lux level in their cabin or the temperature in their cabin right from the mobile app. So what have our customers been able to achieve using 75F? These are the advantages. Up to 50% energy savings on HVAC, which is substantial. HVAC is the largest energy consumption component in any building. And when we talk about, say, 40 to 50% energy savings on HVAC, it's substantial energy savings that we're talking about. Then we've been able to achieve all these savings without compromising on the comfort. In fact, actually improving on the comfort. And since we are a wireless system, we are 10x faster to install, reduces installation time to 1/10. We are when we say we are a containerized solution, effectively we work out of box. Once you buy our system, all these functionality that we spoke about comes out of the box. You don't have to pay anything extra for any other features like in traditional BMSs. Our system provides you with granular control that gives you access to granular information as well as the capability to control your system in a much more detailed and granular manner. As we already spoke, almost all our systems, all our deployments have been able to achieve payback periods of less than 3 years. And complete building analytics and insights can be customized and are customized as per the client requirement. So it's not a standard analytics software that we give. Any particular parameter which the customer is interested in monitoring against any particular parameter, any graph, any analytics, as per the customer requirement is customizable. So this is pretty much about my presentation. Other than that, I'd like to speak a little bit about how exactly do we deploy the system. So it's a two-stage process. First is a site survey process, because in most of the sites that we go in, these are existing sites, and we have to, before we actually commit the energy savings that we'll be able to achieve and the results that we'll be able to deliver, we actually need to understand the existing infrastructure, its state and its state of operations, how efficiently or inefficiently it is currently run. For that, we need to do a site survey, which is done free of cost for the client. So it is generally a 1 to 3 hour process, wherein we would need help from one electrician or somebody who can help us with the equipments installed, and then we prepare a detailed report on the existing infrastructure and accordingly propose a solution and propose the quantum of the savings that we will be able to achieve. Then as a second step, to give confidence to the client and to do a proof of concept and show to the client that these are not mere talks and we actually deliver what we're talking about, we do a pilot, a limited pilot. So wherein at any given chiller or AHU of the customer's choice at their facility, we conduct a pilot where we run the pilot for around a month, for say 15 days, that is 2 weeks, in the baseline mode, where we don't do much, just take the readings and set up the baseline for comparison. And then we, after 2 weeks, we switch the system to smart mode with all our analytics and all our software algorithms on. And then we, after 15 days, we show them the savings and prepare a detailed analysis report, not only on the saving side but also on the comfort side, and we show it to the client that we've been able to achieve this good quantum of savings without actually compromising on the comfort. So this gives the client a fairly good confidence on our technology, and this is how we proceed in the market. This is pretty much from my side. Any questions, I'll be happy to take. We can also talk about few of our clients. So for example, SmartWorks is one of our portfolio clients. We have done a couple of buildings with them, in fact 6-7 buildings with them for as of now, and in most of their buildings we've been able to achieve around 30% energy savings. And that's and just the client giving us 7 buildings one after the other in itself is testimony to the efficiency of our system. And then there are many more clients that we can talk about. You had seen that the list. There's Mercedes-Benz, there's WeWork and others. So, but the point remains, end of the day, we've been able to achieve anything from say 30 to 50% energy savings on the HVAC side, which is very, very substantial. So this is all from my side on the presentation. Any questions, I'll be happy to take.
So thank you, Shamsher, for the great presentation about 75F and all key highlights you have covered over here. So it was indeed a pleasure to have you with us.
Thank you, Shiva.
So audience, by the time we are in process of computing the quiz results, so platform is open for question and answer round. We would happy to take your questions. I can see one question over here. Is there any smart node with higher number of analog and digital IOs? Karan, would you like to
take it?
Sure. I would like to understand what the application is, because normally we might have some other specific device that might actually do the trick.
So this question is from Mayuresh Gangale ji. So Mayuresh ji, if you can put up your question more in elaborative way.
Should I allow him to talk?
Yes, please.
Just a minute. Yes, Mayuresh, please go ahead.
Reji, you can proceed with the question.
Can you hear me?
Yes, sir. Please go ahead.
Yeah. The question was like, is there any product with a higher number of IOs? So the requirement is like typical arrangement of AHU room on a kitchen floor with additional kitchen side equipments like exhaust fans, fresh air fans, and also we have a requirement of monitoring the negative pressure of the kitchen area. So it's a mix of workspace, workstation, and the kitchen area. So in that case, we are having more number of IO points. So how that could be, catered with the 75 of your product line.
Sure. So for kitchen, that would be considered like a system level control, right? So for system level control, instead of using smart node, you would be offering the central control unit, which would host the whole control sequence that you want, right? And if there are any other points that needs to be controlled, we would be providing IO module extensions. So I suppose there will be a point for pressure monitoring, and there'll be a point for exhaust fan.
Okay. So
right. So all of those would be
yeah.
provided by additional IO points.
Okay. So it can be expanded, right?
Certainly.
So system. Okay. So system wise, we'll have a CCU, and rest all points we can have a expander or something like that.
Correct.
Okay, fine. Thank you for the clarification.
So we have another question from Kamal Mulikumarji. How cybersecurity challenges are taken care?
Great question. Cybersecurity is one of those things that IoT BMS face a lot. So the way we have actually made our system, 75F system, very secure, there are a couple of things that we do. So firstly, all of the communication data is encrypted using a 256-bit key, right? All of the data communication that happens from the gateway to the cloud, that is secured using a TLS 1.3. TLS basically creates like a tunnel between the central control unit and the cloud, so that no other data can actually enter the tunnel and your data stays secure. And all of the data in the cloud is anyways encrypted and secured by the latest cloud technologies. On top of that, specifically for 75F, we are looking to get I'm trying to remember the name of the standard. It's escaping. Yes, SOC2. SOC2 standard for data security and assurance. So yeah, those are a couple of ways that we provide security.
Yeah. We have another question. In your solutions package, do you also allow daylight uses to reduce the lighting load?
Absolutely, 100% possible.
One more question we have. Is it possible to get an artificial intelligence report from the system? Let me explain. We have already installed a BMS system and client needs artificial intelligence response. Is it possible?
So, in order for an AI system to work, there needs to be data fed to it. Maybe we can discuss this separately, what the requirement over here is. But yeah, I think I would say it is possible. It would require a lot of data input to be provided, but it can be done.
whether the cloud security is provided as per ISO 19650.
So I'll take that, Shiba. So currently we are planning to adhere to all the SOC 2 specifications and any VAPT vulnerability plugs that could be put into the system. ISO standard probably has more processes and steps in place. Currently, that has not been evaluated. That is something that may come up later on. But we currently will have a VAPT report and SOC 2 compliant security checks and audits.
More questions, please. We are happy to answer. So can we assume no more questions from the audience now?
I think Mr. Nixon Simon want to talk, so should I allow him to talk here?
Yes, please.
Hello.
Yes, sir. Please go ahead.
Yeah, can you hear me?
We
Hello?
can hear you, sir. Yeah.
Yeah. Good evening. Actually, I'm from Bahrain. So I raised a question regarding artificial intelligence. Why? Because recently some of these IoT teams came to our company for a solution for an artificial intelligence. That's why I raised a question like that one. The main concern is that the client, they required an artificial response. Means we have already installed a BMS system there. So for example, if there is a tripping or any alarm, filter data alarm is going to trigger. So the BMS, what BMS will do? Action will be taken only after the triggering. So they need to know from a statistical reference that before this action, they need to know a notification. Is it possible in IoT if we install this IoT there? Because it is a bank and it is a famous bank, that is Arab Banking Corporation.
Yeah, Mr. Nixon, I think this will require a more detailed study to understand the system, right? There are loads of moving parts in this, so perhaps we can discuss this separately.
Of course, because the main problem is that we are using train controllers. I don't know. Last time when I see a slide, it was not mentioned the train. I think it is not that much famous in India, but here the GCC it is very famous. This train controllers. So instead of this train controllers, we are also going for a IoT based control system also. So if your system is capable, then we can able to do some projects, I think.
Certainly, we'll reach out to you separately on that.
Of course. And is there one more doubt? Is there any limitation on the IO modules for the connection? Means, for example, in our train, it is limited to some 65 to 75 devices. After that, we need to renew the license and everything. Means 5,000 points, 10,000 points. Likewise, is there any limitations in the IoT?
There are no points limitation because we usually provide a bespoke solution, right? So I'll give you an example. The device can actually handle more than 1,000 or 2,000 points. But because of the distances or devices that need to be controlled, we would provide a separate device for separate systems, right? Because we want to keep the system scalable. We don't want to have a singular point of failures.
This 2,000 or 1,000 point is very limited, I think, because currently we are using 10,000 point and it is already, we cannot able to handle, even though it is a 10,000 point. So this 1,000 and 2,000, I think it is very limited point, I think.
Because I think your expectation over here is that this will be acting as a supervisor. But for IoT BMSs, the concept of supervisor is not there. The supervisor, so to speak, would be on the cloud, right? We have a local controller and a gateway, right? And because it is localized, it has certain limitations. Now, we can also increase the number of points depending on the application. That is certainly possible. So it's always good to look at what is the application.
Okay. Okay, thank you, Mr. Karan Chaturvedi.
No problem.
Any more questions? So there is no more questions available in the chat box. So can somebody please speak? Any questions? So by the time we are compiling the result of quiz, so I would like to Mr. Syed Hidayat Ali, our director, channels in BDM, please put some words about vote of thanks.
Hey, thank you, Shiba, Shamsher, Karan, Shilpa for the wonderful insights and giving the entire participants over here a knowledge about IoT. I trust with regard to the fantastic questions brought over by the team, it gives an immense pleasure of understanding that this session, knowledge sharing session was up to the point, and definitely more engagements are going to happen as per the questions coming out from here. So good evening to you all, the Delhi ISHRAE chapter team, delegates and the participants over here. It's my privilege to have been here, asked to propose the word of thanks for this occasion. And it's a wonderful privilege over here to be part of it over here. And I, on behalf of 75F Smart Innovation, extend a very hearty word of thanks to all the delegates, participants who have blessed us with their time and they're from their busy schedule and have given us almost more than 2 hours of time to attend this workshop on the IoT BMS to a very scintillating level. Thank you. I also wish to, in fact, extend my gratitude and thanks to the Delhi ISHRAE chapter team, Mr. Ashish Gupta, President, Priyank Garg, President-elect, sorry, and Mr. Siddiqui, ISHRAE Chair, Tapas, and Purnima for giving us the encouragement, support, and the platform to host this wonderful workshop and knowledge sharing session on IoT BMS. And also extend my special thanks to my 75F team, speakers and panelists, Karan, Shilpa, Shiba, as well as Shamsher for the exemplary participating and also sharing the insights about 75F and the applications and the standards on the IoT and answering all the questions. So thank you all for making this event very successful with your contribution and look forward for more engagements. I would like to share here. Okay, the host has disabled participant screen sharing, so I would request if they can enable the sharing of the screen, and wherein I'll share the
Yeah,
details
please go
of
ahead, sir.
contacts.
Please go ahead.
Yeah.
Yeah.
Thank you, Mr. Tapas. I hope the participants can see the screen.
Yes, sir.
Yeah. So the team, the respective participants, delegates can reach out to the 75F below email IDs. And for more information on, they can log on to www.75f.io for more insightful information about the smart IoT based BMS technologies, and also go through the case studies and the applications and the wonderful products what we have. So please make a note of this, and we would request that if you can reach out for any further clarifications to these respective team over here, Siddiqui and Sumit over here. So thank you all, and I look forward for more interaction and engagements. And Shiba, over to you.
Yeah. Thank you, Syed, for all the words. So audience, finally, we have received the results of today's quiz. So I would like to announce the name of top 20 winners. Mr. Somnath Sinha, Dr. Amit Sharma, Bilal Hassan Sabzwari, Satish Nanjappa, Ushmila Devi Sohar, Ali Mutawassilin, Subrata Devnath, Benedict Shinku, Rupesh Tyagi, Kapal Murlikumar, Ima Krishnan, Rakesh Makwana, Samta Bajaj, Pramod Khatana, Atul Mishra, Mayuresh Kangale, Mohammad Hamid, Anup Kumar Karni, Manpreet Saluja. So congratulations and many thanks to all who have participated in the quiz and today's session as well. So yes, as well said in the beginning of the session itself, gifts will be delivered to the correspondence address. So you will be received a mail to confirm your address, enable us to deliver all your respective gifts. Okay, so thank you everyone. Thank you ISHRAE team. Thank you all participants. Thank you panelists. So any closing words from ISHRAE team? Over to Tapasji.
I think thank you, ma'am, for giving me the opportunity for the final few lines of words. So it's great. I mean, it's a great experience on behalf of Delhi Chapter. I would say many questions were there. What we observed that delegate involvement was there. That was great. Many questions has been asked. That was answered by your team very well. And definitely we're looking forward this kind of session again in future as well. So create awareness. Or ISHRAE basic theme is to disseminate knowledge. So I mean, you people who support us for disseminating knowledge. And one request from the attendees or delegate, one who is non-member of ISHRAE here, so they can join us. There is a link when you go to our website www.ishrae.in. You will find the link to join ISHRAE, and there are very nominal fees, and you will enroll us for the 3 years and 10 years of the membership, and you can get more and more knowledge. This is the way, this is the platform. You can get knowledge, you can get network, you can get events related to your society, related to your industry, related to your businesses. So it's a great platform, I would say, finally. So I think this is the way we can go forward, holding the hand of each other's. Thank you very much. So I think we have done for the day. Anything else you would like to share, or we should close the session for the day?
Okay, thank you everyone.
So with your permission, ma'am, should I close the session?
Yes, please.
Thank you. Thank you, everyone. Thank you, panelists. Thank you, attendees. Thank you.
Thank you.